Hello, and in this video we're going to be talking about what is proof of work. And if you like this content, if you like blockchain stuff, cryptocurrency, peer-to-peer, and programming tutorials, please subscribe. I'm trying to do a 30-day challenge where I post a new video every single day. Going pretty good so far. We'll see. Okay, so proof of work. Proof of work is a system that operates by requiring participants to engage in a certain amount of work. That sounds kind of redundant, but it's not. It makes sense. This work is done by a computer processor. Usually the work is to solve like a specific problem. A very popular problem is hashing data at a nonce, so that the hash has a certain number of leading zeros. This might sound super complicated, so I'm going to break it down piece by piece for you there. A hash function is essentially it generates a fingerprint of some kind of data. Often these are displayed as long alphanumeric characters. So we've got an example here. So here I'm using the SHA-256 hash here, and I'm hashing the name of the channel, Mr. Rigdon's channel. And this is what we get. We get this long down here. Let's see if I got my pointer. Oh, does my pointer work? Hopefully it does. All right. We get this long alphanumeric number that's super, super long. And that is the SHA-256 hash of this string. If you change even a single bit of the data, the entire hash will change. So we're going to do a little example here. I'm going to remove the apostrophe. So there's an apostrophe here, and now it's a totally different hash. You could use this. This would be the same thing for images or binary files or text files, source code. It all to a computer. All this data is just ones and zeros. So you can do a lot of things the same. And so hashes are a good example of that. It really doesn't necessarily care so much what the data is. It'll hash it. So here's a little side-by-side in case you missed the different hashes. So this is the hash with the apostrophe, and this is the hash without the apostrophe. You can see they are completely different. Okay, now moving on to the nonce part. That might confuse you and confuses some people, so I'm going to give you the most simple explanation, and it really is the best one. A nonce is just a number only used once. It's kind of a little trick there. It does get more complicated when you start getting into cryptographic nonces, but for our purposes, a nonce is just a number we're only going to use once. So we're going to combine that nonce. So it's just some, I don't want to say random number, but it can be any random number, and the data, and then hash it. And this is going to change the hash, right? So if you keep on changing, and the hash changes every time the nonce changes, all right? So I was skipping ahead of myself there, right? So if every time we hash some data, we change that nonce, the hash is going to be different each time. And if we do this enough times, eventually we're going to happen upon a hash with 3 leading zeros. All right, so this is what we're looking for. This is what the puzzle is. They're going to give us some data. Sometimes it's just a little string like Mr. Rigdon's channel, or sometimes, on some of these cryptocurrency things, it'll be, a 1 megabyte block or some other size. I don't really know what the sizes they really use, but it's going to be just some data, and they're going to hash it with a nonce. They're going to do it over and over and over and over again until they eventually find some nonce that will hash with that data to make a leading zeros like this. So this would be the valuable thing with these 3 leading zeros. And this can take some time, a lot of time. It kind of depends on how many of those leading zeros you want. And it can take a lot of CPU time, a lot of personal time, a lot of energy. But once we have it, we've solved the problem. We've solved the puzzle, rather. That hash and the nonce are the proof that we did a bunch of work, right? There's no way you could figure out what that nonce was and what that hash was that had the 4 leading zeros for that particular data set without doing a whole bunch of work. And what's cool is that if we give somebody else, let's say we say, hey, I solved that puzzle. And everybody else is going to say, hey, prove it. And we're just going to give them the nonce and the hash. And then they're going to really quickly, just once, run the hash through. And if it matches, then they know that we were right. We solved the puzzle. It is our proof of work. So there are there are many other proof of work systems out there. This is just a little simple example. In real life, it'd be way more complex, but this is just kind of like, this is the YouTube version, the YouTube video version. So hopefully it made sense to you. And have any questions, ask those down below. And if you like this video, please hit that like button. And you can, of course, always follow me on Twitter. And yeah, I hope you found this video useful. If you do, or if you want to know more about proof of work and how do these things really work, just ask me in the comments below, and I will try to make another video where I dig more deeply into proof of work and more specifically as to maybe what the different coins require. So yeah, thank you for watching.